Ora si registrerà la conferenza.
Excuse me, can you see the slides?
Yeah, we can see them.
Okay. Yes, thank you for the introduction. So I'm Dmitrij Lagutin from Aalto University, Finland, and I'm working as the coordinator in the SOFIE project. And I will first introduce the project and the SOFIE framework, and then our pilots will continue to describe how SOFIE is used in real-life use cases. So as an introduction, as you probably know, the fragmentation is a major issue in the Internet of Things world, that we have a lot of different IoT systems which are basically closed silos which do not work together with each other and are not able to exchange data or actions between each other. And then this leads to different kinds of problems, like high barriers of entry to the market, which leads to reduced competition, that big players easily can dominate the market and the small players are not able to join the market because their platforms cannot be compatible with others, and also the worst security and privacy, because often the manufacturers in a dominant position are requiring the customers to put the private data in the cloud and so on. So the SOFIE project is the Horizon 2020 project that started 2 years ago, and the aim in SOFIE is to provide a secure open federation for existing both open and closed IoT platforms, and as enabling technology we are using distributed ledger technologies such as blockchains. And our goal is not to require any changes to the existing IoT platforms, so we are like doing federation, we are not building our own platform, and also in the long term SOFIE enables open business platforms and eventually open data markets. So that was for the introduction. Next I will talk briefly about distributed ledger technologies, or DLTs. There have been a lot of hype in recent years about DLTs, and it is important to understand what exactly is the main property and what they enable. So on a technical level, main property of the DLTs is immutability of the data. So after the data has been inserted to the ledger, it cannot be changed afterwards, at least without participants noticing that. And this in turn enables distributed trust between the participants in a DLT, and also DLTs enable higher degree of automation through the use of smart contracts and related technologies. And there are a lot of different types of DLTs available. So most well-known one are open DLTs like Ethereum or Bitcoin, but the DLTs can also be semi-open, which means that read access is open to everyone, but the write access is regulated, or the DLTs can be fully permissioned or closed, in which case both the read and write access is regulated. And in real-life systems, most of the DLTs will be closed or semi-open, simply because running a fully open DLT like a Ethereum or Bitcoin would be more too expensive for most purposes. And because DLTs have different properties, SOFIE utilizes multiple DLTs in parallel. The approach we are calling the interledger. And in SOFIE, DLTs are used for various purposes, such as storing hash of data to public ledger for non-repudiation, recording access control policies and access control related transactions, and trading assets in a transparent manner on a ledger. And you will hear more about these use cases later in the pilot presentations. And on the next slide, we have SOFIE architecture described. So at the bottom of the figure, we have existing IT platforms and devices, gateways, and assets. At the top, we have IoT applications and clients. And on the left side, we have different kind of ledgers, which can be both open and closed ones. And then in the center and center left, we have the SOFIE framework. And here we have federation adapters, which will interact with the IoT platforms. And then we have 6 SOFIE components. And the SOFIE components include interledger, which bridges multiple ledgers together. Then we have identity, authentication and authorization, and privacy and data sovereignty components, which are responsible for managing identities for both users and devices and enable users to share their data in a privacy-preserving manner. Then we have a decentralized marketplace that enables trading assets on a ledger in a transparent manner. And the semantic representation component enables semantic interoperability between different IoT platforms, and discovery and provisioning component allows then discovery and provisioning of a new IoT platforms that would like to join to the system. And then, yes, on this slide, we have a list of components again. And also we have released our framework as open source under PASH license on GitHub. And we are, of course, planning to have further releases before the end of the project. So if you are interested, you can visit our GitHub page and check the framework. So next, I will briefly mention our pilots, which will then be described in the rest of the webinar. First, we have a food supply chain pilot in Greece that provides customers accurate data of growth and transportation conditions of the agricultural produce, such as grapes. Then we have decentralized energy flexibility marketplace in Italy. So here the goal is to avoid the reverse power flow in electricity grid. The electrical vehicle owners are provided incentives to charge their cars in such a way to use the excess energy from the grid. Then we also have a decentralized energy data exchange pilot in Estonia that allows users to share their electricity consumption data in GDPR compliant manner with third parties, which can then in turn develop novel application based on the data. And context-aware mobile gaming pilot in Finland that allows gamers to interact with IoT devices such as beacons as a part of their gaming experience, and also trade the virtual in-game assets in a secure and flexible manner. Okay, so I've tried to be brief to leave more time for our pilots. So this concludes my introduction, and also I would like to remind that we are organizing a joint workshop with Cyber Watching in 2 weeks on 18th June, and in that workshop you can hear more results of the SOFIE project, so everybody is of course welcome to participate there. And also we have here on this slide there's links to our website and once again to our framework page. And the chat seems to be empty, so I think we can move to the pilot presentations, starting from the food chain pilot, and Yannis can continue with that. So thank you from my part.
Hello everyone. Let me just first check that you can see my screen properly.
Yes, we can. Fine.
Okay, great. I'm Yannis Oikonomidis. I'm from Synelixis. I'm going to present you the food supply chain pilot of the SOFIE project. In this pilot, Synelixis and Optimum are involved. Synelixis is an expert in IoT systems for the field, and Optimum is an expert in a company in the warehouse automation. And the last part of this pilot is 7 Grapes, which is a company that has facilities, field facilities, and obviously for grapes. First of all, the objective of the food supply chain pilot is to have to provide to all the actors involved with a way to reliably track their products. All the actors are the producers and transporters, supermarket employees, and of course the consumers. With this, we aim to also provide them a way to verify and get track of all the information that covers and spans from the beginning, from the field to fork, the whole food supply chain up to the supermarket. The way we were trying to we are doing this is by splitting, first of all, by splitting the supply chain into segments. The first the segments is the producer, where the actual product is being created, and then the transportation, the storage and the distribution facility, and the last one is the supermarket. The second step is to use RFID enhanced boxes and other sensors to make this tracking of the product information feasible. And we also making some progress in the handovers. We're tracking the handovers between the different actors. And the last thing we're performing is to utilize the distributed ledgers and to tamper-proof the product information. I will go to the next slide, which shows these segments that I was talking about. The product starts on the left side of the screen on the farm, on the field, where the Synfield IoT deployment. It's a product from Synelexis that is a station that has many sensors for monitoring the field and the crop is being deployed, and then it goes to the transportation where different let's say trucks have been provided with sensors that are monitoring the status of the product within the vehicle, and then it is of course a warehouse where the product arrives for storage until its distribution to the next entity of the chain. In the warehouse, there is automation and IoT platform is involved, and also this is a product that comes from Optimum, and it has been enhanced for the purposes of this project. And the last step is the last segment after transportation from the warehouse is of course the supermarket, where the product is made available for the consumers to consume, and having some using QRs in order to provide the consumer all the information that has been generated from the beginning of this route. Now here is what we aim, how we are utilizing the SOFIE outcomes to provide what we need for this for our objectives. In the bottom, you can see the different IoT platforms that are being collaborating for this food supply chain. There are a smart farming IoT platform, there's a transportation IoT platform, and there's a logistics IoT platform. And on top of them, what we are using from SOFIE is we are applying the SOFIE's federation architecture, which includes some components, and not all of them. Some what we utilize in this pilot is the authorization, authentication, identity component. It's a semantics component, and also the interledger component, as well as the privacy and sovereignty component. These all are being enhanced with services that are specific to the pilot, and the DLTs that are being used. And on top of them, we have this provenance chain business platform, which its final goal is to provide two features. One is the product traceability, to securely trace products by using also QR codes. And the second feature is the audit service for offering transparency and trust in cases where auditing process is needed. I will go to the next slide, which shows the high-level architecture. As you can see, in the bottom, we have these three IoT platforms, which are separate, and by using the federation adapters concept that is being introduced in SOFIE, we managed to make this federation of these heterogeneous IoT platforms. These are all connected to the main backend, let's say, where the SOFIE components and services tailored to the pilot are cooperating in order to provide the end application. The web application that's being used by the different actors triggers events that are being stored in the private consortium ledger, which is an Ethereum DLT, and the final, let's say, in the end of the path, we have a transaction hash that's being generated and is being stored in a public ledger for the audit process purposes. Just as a summary, the technical features that we have used in this pilot is we managed to tamper-proof the different activities that happen along the chain. We have provided access control and authorization based on smart contracts. We have managed to achieve interoperability with these federation adapters that use also the World of Things concept of semantics. And we provided also an adaptable web interface to the users. And in terms of benefits for the food supply chain domain, we're offering digitization and automation, collaboration, and information sharing across the whole ecosystem of companies that are willing to work with each other. Using also the DLTs, and we have managed to provide a proof of product ownership and responsibility notion without the need, of course, of a central authority. And with the use of the public ledger and the interledger component of SOFIE, that's in the core of this enhancement of the transparency and the trust between the different entities of this pilot. I think I'm okay. I can give the floor to the next presenter.
Yeah, thank you, Yannis, for your presentation. I may ask if from the audience there are some questions. I just remind you that if you prefer, you can use also the chat. So the next one is Giuseppe, right?
Yes.
Perfect. In a moment, I let you present. Okay, perfect.
Okay. Hello, everyone. Can you see my screen?
Yeah, it's fine.
Okay. So I'm Giuseppe Raveduto, and I work as a researcher in Engineering Informatica Research and Development Laboratory. Today, I will present our work in the Energy Flexibility Marketplace pilot of the SOFIE project. Our pilot investigates how the fleet managers and the distribution system operators can cooperate using a marketplace to balance the production from renewable energy sources with the consumption of a fleet of electric vehicles. Distribution system operator, or DSO, is responsible for operating, maintaining, developing the distribution system in a given area and the interconnection with other systems, while the fleet manager is in charge of scheduling, routing, and maintaining the fleet of transport vehicles. The main issue that we want to solve is that the excess of production from renewable energy sources may cause imbalances on the electric network because it's an uncontrollable source. In our scenario, the DSO can collaborate with the electric vehicles fleet managers in order to handle energy losses, voltage deviation, overload, and reverse power flow. So essentially stabilizing the grid. The electric vehicles are then considered the flexibility resources able to provide services like consumption or production peak shaving or load shift that are useful to avoid congestions. The enabling technologies are the IoT platform that allows the business handling. So, for example, the electric vehicle monitoring or the electric vehicle supply equipment management, and also the advanced monitoring infrastructure of the DSO. Together with the blockchain and the interledger component that are used to manage the local flexibility marketplace. The platform was designed to consider the needs of the stakeholders. So the DSOs are facing an increase in distributed renewable energy sources and the electric vehicle supply equipment penetration. So they need to increase their hosting capacity. The flexibility marketplace so helps reducing the cost in infrastructure because it's possible to shave the consumption or production peaks. Additional benefits for the DSO are the exploration of new business models and the improvement of the power quality. And on the other hand, for the fleet managers, the fleet managers can reduce the operational cost thanks to the energy retail marketplace and also the incentives awarded by participating in the flexibility market that will cover part of the electric supply. The main actors that we identified are the already mentioned DSO and fleet managers and the energy retailer. To support our scenario, we designed a platform which integrates the SOFIE components with the existing pilot infrastructure as shown here. Without going into detail for each specific component that anyway are all publicly released and documented, I want to focus on the decentralized blockchain marketplace that is built using the Ethereum smart contract together with the interledger component to store the DSO flexibility request and also the electric vehicle flexibility offers, ensuring transparency and auditability thanks to the matchmaking logic that is embedded in the source code. And also the federation adapters that are necessary to access the data provided by the IoT platforms that are already present on the pilot side. So the smart meters, the vehicles, and the charging station. Let me show how we implemented this. So the DSO operator interacts with the platform using a dedicated dashboard. You can see how the dashboard presents real-time power data from the IoT smart meters and the power forecast based on historical data. The operator can also create a market request directly from here using the form that you can see on the bottom of the page. The dashboard presents also the list with the past and the active marketplace requests. So each item on the list represents the associated offers received from the fleet managers and also the request details. For each request, in fact, we need to specify a time window, a charging station that has to be present in the zone that we need to balance, the quantity of energy requested, and also the quantity of tokens that we are offering to fulfill this request. The fleet manager operator can interact with the platform using its own dashboard. From here, the operator can react to the marketplace requests, so submitting a new flexibility offer, and can consult the list of active campaigns on the marketplace, and also monitor the fleet and the charging station. Using the same dashboard, the operator can also create new energy supply requests on the marketplace, so ensuring that the power supply that he will need to fulfill the DSO can be obtained cheaply. Thanks to the integration with the IoT platform, the fleet manager can also check in real time the information about the charging station and vehicles. And in this case, we can see, for example, the details of an ongoing request. The process ends with the delivery phase. So after the vehicle is charged, the token payment is unlocked. And as can be seen here, the tokens can be managed using any standard Ethereum wallet. The first evaluation shows that the charging session rescheduling can increase the self-consumption without interfering with the activities of the fleet. So the simulation results show that the potential contribution from the electric vehicle on the balancing the production with about 50% of charging sessions that could be potentially scheduled for balancing the production peaks of the district. In this way, it's possible to decrease the energy taken from the grid for the charging station needs, but also increase the self-sufficiency of the electric vehicles. That is the share of the solar production drawn by the electric cars charging sessions. On the other hand, thanks to the usage of renewables by the vehicles, we can see how the prosumers can increase the money saved. Considering the average retail price of 0.26 euro per kilowatt hour, and also the average price for the energy that is sold back by prosumers to the retailer, that is 0.13 euro per kilowatt hour, the self-consumption allows each prosumer to save 0.13 euro per kilowatt hour produced. Also, considering this, we can also see how this contributes to reduce the CO2 emissions. In fact, each kilowatt hour of energy that is taken from the grid is associated with a quantity of CO2 of almost 500 grams due to its production. In summary, the platform offers different benefits for the actors involved. The DSO can forecast the occurrence of possible grid issues, and thanks to the IoT advanced metering devices, and can also balance the local supply accordingly creating the flexibility request on the decentralized marketplace. The fleet managers can reduce the management cost of the fleet. Thanks to the marketplace, it's possible to select the most convenient retailer anytime, and the incentives awarded by the DSO for helping with the flexibility provisioning helps to cover part of the electric supply cost. And finally, for all the users involved, we provide a rapid and user-friendly mechanism to negotiate micro contracts on the fly, and also the security, transparency, and auditability of the operations that are granted by the blockchain. And thanks to the federative approach of the SOFIE project, the different siloed IoT system can interoperate. And so this is true also, for example, for new actors, for example, new fleet managers that want to join the marketplace. Okay, so that was the last slide. So thank you for attending. If you have any question, otherwise I left the floor for the next presentation.
Okay, I think we can move on with Liis. And always, if anyone has some questions, you can use also the chat. In this way, we can move on and at the same time register also the questions meanwhile the webinar is going on. Thank you. Liis, if you want to start. Okay, perfect.
Hello, everyone. I assume that my slides are okay and you can hear me. I am Liis Livin, and I'm from the Estonian company called CarTime. And I'm the kind of person who makes magic happen when research, technology, and innovation things need to be translated into simple words, and when information needs to flow smoothly. So I'm the communication manager in CarTime, and I also lead the communication activities in the SOFIE project. CarTime is the world's leading blockchain company with actual production deployments in governments and Fortune 500 companies, tackling fundamental challenges in cybersecurity. And today we have several offices and around 200 employees around the globe, and we are focusing on data-centric cybersecurity solutions in defense, telecom, energy, government, and space sectors. But in the energy sector, CarTime is both deploying production-grade cybersecurity solutions to utility companies, as well as investing into innovation and research. So today I will give you an insight into what we are doing in the SOFIE project while we are leading the energy data exchange pilot, and how we plan to contribute to the future energy sector. Even though the world is changing rapidly, the challenges actually in the energy sector remain and need to be addressed. And these three drivers are forcing the energy sector to seek new options and solutions, and are actually affecting our everyday lives. So from the regulatory side, we have the EU Clean Energy Package and the GDPR. Yes, we have the guidelines, they are set, but how to actually achieve them, especially from the technical side, this still remains to be solved. Secondly, the financial aspects. The race to offer suitable energy flexibility services to the market is ongoing. This includes getting data access, customer onboarding, and also secure solutions. Thirdly, a simple thing from the consumer's perspective. Everybody wants to control their own data. So keeping in mind these challenges, these are the problems and the pain of the consumers and customers that we are solving. We will enable data access, both from household and data hub level. We will deliver an auditability and privacy solution, and we will provide integrity of energy consumption data and transparency mechanisms. So to make it simple, from a citizen's perspective, if you use our solution, you will have an option to choose your energy provider and also see what is happening with your data. And from the service provider perspective, you will have the access, auditability, and integration related problems solved, and you can focus on the core business and delivering service to the customers. So this is the solution that we are developing in the SOFIE project, and we hope to solve all the four named problems and also contribute to achieving the goals that the energy sector wants to reach in the upcoming years. This is the basic concept and building blocks of Project SOFIE Estonian Energy Data Exchange Pilot. We built a network where SOFIE adapters are installed, and the interaction between the energy sellers and consumers is enabled. On the bottom here, you can see the data sources. They are the standalone smart meters, for example, in the household. They are also the national data hubs and regional solutions that are actually already existing, but are not able to deliver data as needed. On the upper part, there are flexibility services providers needing access to the data, and all participants on the upper right box that require the reporting, auditing, and traceability functionality of data access control. In the center, you see the SOFIE energy grid adapters and the SOFIE federated platform that are the main components developed during the project. Using the Hyperledger Indy, verifiable credentials, decentralized identifiers, and CarTime's own DSI blockchain, we enable the governance and traceability when accessing the data for data owners and also for service providers. So the adapters will enable users to connect to data sources and deliver matchmaking, cryptographic proof, security of transactions and logs to all parties involved. And from the service providers and data hub operators perspective, the key drivers to be onboarded in this is the reduction of integration costs, as most of this is solved from the adapters and the SOFIE's federated platform side. So how does it all look for a consumer? Basically, a consumer hands over her data through a mobile or computer application and gets an overview of her energy consumption and production, and then can benefit from this information. For example, get a cheaper price or sell her own produced energy. So firstly, the consumer gets here on the picture the energy consumption and production overview. The blue lines present the consumption, daily consumption and nightly consumption, and the red line is the production side. So you can see the production has been 0 for this consumer. And also the consumer then has an overview who has accessed her data, and if she wants to, she can revoke the access with just one click. And most importantly, the consumer will see the cryptographic proof for the audit trail about her energy data, so all about access and usage of the data. When going from an end user perspective to a broader view, our vision is that we plan to scale this up to the whole Europe, including the energy retailers, brokers, and also network operators. But the central focus remains still on the data owner, and the goal is to enable seamless exchange of data in Europe with just a few clicks from the data owner's side. So this is where we want to be with the technology and in the energy sector transition. The goal is to interconnect the national smart grids of different countries. This means at least 500 million metering points that need to be available in a secure and compliant way. As a conclusion, there are several key aspects to keep in mind. For example, we rely more and more on the data, and being able to access it securely is essential for future services and in energy sector for sure. And also, especially in the energy sector, decentralization is important as the free and open energy market goes beyond country borders. This sets limits how to control it centrally. And of course, you need to think about the security and privacy before building the solutions. So this needs to be solved together with the infrastructure. From our pilot's perspective, the proof of concept we are developing here in SOFIE is currently in the finish line to be ended in 2020. And we can currently assure that decentralized identifiers, TSI blockchain, and the technology we use for authentication and auditing are working. And last but not least, in the current setup, we can prove that the data owner has control over the data. So to sum up, SOFIE's free energy data pilot focuses on the liberation of energy data, envisioning and empowering a future of smart energy consumers. Everyday citizens' control over their energy consumption and circulation in our vision helps to grow their awareness and to make economically wiser decisions, and at the end of the day contribute to the planet's sustainable future. Thank you from my side. I will happily give the word to Max, who is the next presenter.
Thank you, Liis. And let me just share my screen. Okay, I think you should be able to see the presentation now.
Yeah.
So, hello everybody.
Perfect.
My name is Max Samarin, and I'm a researcher here at Rovio Entertainment, a Finnish mobile gaming company. And we are indeed one of the 4 pilot companies here in the collaborative SOFIE project. So what do we do in this project? We want to explore the potential use cases of distributed ledger technologies and the Internet of Gaming and the Internet of Things in gaming, and test the business opportunity. We want to see if these technologies would make sense in gaming. And so as we started to research this, we started to think about a hypothetical imagined scenario in which IoT devices are used for location-based gaming. So basically, these devices can be, for example, Bluetooth beacons that broadcast signals, and therefore they can be used to position players in location-based games. But all those devices, they are owned by different actors, and here we can see that we start to have lots of different partners in this kind of a ecosystem. So we have the players who play the game, we have the game designers who design the challenges and the games, then we have the beacon owners, as well as the advertisers and real points of interest in the real world locations that the players visit. So it at least seems like it's worthwhile to explore if a decentralized if such an ecosystem could be built on a decentralized platform. So that's what we are exploring. And here we have some more concrete examples of DLT and IoT in games. So for example, if cryptocurrencies would at some point become a more mainstream method of payments, that is something that game companies could take into account in in-app purchases, and also some virtual items and rewards can be stored on blockchain, and that could potentially provide benefits such as a sense of true ownership and the ability for the players to sell their in-game assets as they will, and also if the in-game assets that players earn are separated from the game itself, and if they are used, for example, in other games as well, then if the first game gets killed, then all the progress of the player it can still be preserved, because the items are still owned by the player, and they can still potentially have value in other games. As for IoT, especially inside buildings, Bluetooth positioning can have better accuracy when compared to GPS. So, for example, if you want to know which floor the user is located at inside a building, GPS is not so good for that anymore. But you can have that information if you have some Bluetooth devices around. And also in competitive games, you really want to make sure that the player visits the real-world locations they say that they are visiting, because GPS can be spoofed very easily, and that is not so easy to do with Bluetooth devices. So when we started researching this, we created a small scavenger hunt game prototype. It's a very simple prototype. It's a very simple prototype of a location-based game. So in it, the player opens the app and they can browse nearby hunts, and each hunt is just a series of real-world locations that the player has to visit, and at the end of the hunt, they get the rewards. And while they are playing, they receive clues on where to go next in the form of riddles, and once they arrive at the correct location, they get a task in the form of a text question, and the player has to type in the answer based on observing their physical surroundings. But so the rewards that the players receive, they could be, for example, very relevant to the place they are visiting. So if let's say a cafe decides to organize a hunt inside such a game, then if the hunt ends in their cafe, then they could offer, for example, some discount vouchers to the players. And if the discount vouchers are stored on a DLT separate from the game itself, the player might have more freedom in selling that asset to others. And in return, real-world businesses could get more customers this way, for example, museum, cafes, and whatnot. And if also any rewards that the player receives, if the game designers decide so, they can be used even across games, and this is where the DLT helps. Of course, you can do the same thing with a normal, a traditional game server, which would be even much easier to do, but let's say that the game is killed, then the value of the item might still be preserved if the DNA of the item is still used in some other context. So as a very small example here, on the left side, we have a companion application where the player can browse their virtual items that they have earned in this Scavenger Hunt game. In the middle, two screenshots, we can see the player actually playing the game, going to the different locations, and in the end, they receive a virtual item reward. And then in the very last screenshot, we can see that the same item reward has appeared in the item management application. So a bit of a high-level overview of how this is done. So here we have the mobile game client of the Scavenger Hunt. It's created in Unity, and when the player runs around the real world, the mobile phone detects Bluetooth beacons for positioning. Then the game it talks with the game server, which is hosted on AWS, which then in turn utilizes a managed blockchain Hyperledger Fabric for specific functions. So I think the key takeaway from here is that if you make a blockchain game, you don't have to do everything on blockchain, but you have to really think carefully about what are the benefits that a DLT brings to your game, if any, and use those on the DLT and use a normal game server for everything else, basically. And in our case, the same managed blockchain can be used by other applications, like the item management application in our case. And in this scenario, we also have we'll also have the link between the managed blockchain and a public blockchain where the trading between different players would happen for maximum transparency, and that's where the SOFIE Interledger would come in. So how does SOFIE help us? Well, SOFIE provides several useful software components that can be used in our pilot. So, for example, the discovery and provisioning component, it allows a mobile client to discover what kinds of IoT devices are there around and see which ones are suitable and add them to the game's database, so that if we imagine that in the future, if we will have more and more different IoT devices like temperature meters and whatnot, maybe the same devices, if they broadcast signals, maybe they can also be used for location-based games. So it's important to have that domain of IoT devices expand as passively as possible, and that's where this component helps. The semantic representation component, so basically each IoT device would have a small file in it that describes its functionality. So the discovery and provisioning components see what the device is capable of. Is it suitable for this specific game? If yes, then it can be added to the game database. And then we have the Interledger. The idea, at least, is that we would have a link between a public and a private DLT. So in the public blockchain, it will be used for the purposes of maximum transparency and trading, but it's also slower than a managed blockchain. So the managed blockchain is used for everything else DLT related, and that's also where all the different applications that use the same blockchain, that's where they connect, and the managed one. And also we have the marketplace component, which would enable the trading of the assets. So that's our pilot in a nutshell. So if you have any questions, I will be happy to answer them, or you can also shoot them in my email, or if you have any insight or ideas or anything related to blockchain or IoT within gaming, I will be really happy to hear and maybe bounce around some thoughts. And yeah, thank you for listening to this whole SOFIE webinar. I'll also include here some links so you can visit the SOFIE website for some more information about what we do and what we have. We also just recently published our first framework release on GitHub, so you can check that out on the SOFIE GitHub page. And also, if you want some more information about this EU project, you can join us in 2 weeks' time on June 18th when we have another workshop. So thank you.
Yeah, perfect. Thank you. Thank you, all of you. And I ask to our audience if there are some questions to our presenters. We wait some minutes, and then I can conclude with some more information about this webinar. Thank you. We wait for your questions. Also, I can share your link in the chat. In this way, it is easier to join the link in the chat also of your project, the SOFIE project, and also of the ngiot. Okay, perfect. So if there are no questions for the moment, I just want to remind you that this webinar has been registered, and you will find it both on the ngiot YouTube channel, and also the event page is available on the ngiot website and also in the SOFIE website. And once again, I want to thank the ngiot.eu project to make it possible. I am part of the Istituto Italiano Privacy, and I have organized this webinar together with Pasquale Nichino from Archimede Solution and with Francesco Capparelli, which is my colleague from the Istituto Italiano Privacy. And we are part together of the work package 2. And I would really thank our SOFIE project colleagues, so Dmitrij, Yannis, Giuseppe, Liis, and Max, which share with us all this precious information. And we hope to have you in our future webinar too. And so thank you everybody to have been with us today.
Thank you. Bye-bye.
Thank you.
Thank you. Bye.
Thank you.
Thank you.
Bye.
Thank you, Alice.
Bye.